This problem demonstrates the role that variability plays in business decisions. For part A, we'll need to use the error-long loss function table to determine the probability that the movie will not be available, so that we can then in turn determine the likelihood it will be there. To do this, we'll start out by calculating R, which is the ratio of activity time, or P, over inter-arrival time, or A. The problem states that the average rental is 36 hours and that a customer comes in looking for the video 15 times per day, which means that over a 24-hour period, the inter-arrival time is 24 divided by 15. This gives us an R of 22.5. Since we know that there are 9 videos that the store currently owns, that is our M. And we can use these two values to find the probability that a movie is not there using the error-long loss table. That probability is 0.6244. The question asks for the probability that the movie will be available, though, so we'll take that and subtract it from 1 to get a probability that it is there of 0.3756. And that's your answer to part A. Moving on to part B, we need to determine how many movies are rented each day. To do so, we'll use the flow rate formula, which is flow rate is equal to 1 over A times the probability that it is there, or 1 minus PM. We have these values already, so we can just plug them in. 1 over 24 divided by 15 times 0.3756. This is equal to 0.235 movies per hour are rented. Making this a daily figure, we multiply times 24 and the $5 revenue per movie for a daily video rental of $28.17 for the store. For part C, we now need to determine how many cases of children coming in where there was no movie available. So for that, we'll use the customer's lost formula, which is equal to 1 over A times the probability that no movies were available. Again, plugging in our values, we then get an answer of 0.39 customers per day, or per hour, that were unable to rent. Converting that to a day rate, you multiply times 24 and the $1 penalty. And the store is therefore paying out $9.37 per day to children who could not find the video. Now, to determine the payback period for part D, we'll need to repeat the previous 3 calculations using an M value of 10 rather than 9, signifying that they purchased the additional copy of the video. Then once we know the revenue the store is making per day and the penalties they're paying to disappointed children, we can compare this to the original values and figure out how many days it would take to recoup the $50. So for part D, our new probability using that M of 10 is 0.5842. Then we can plug this into the flow rate formula and get a daily revenue that they're making on the video, which is equal to $31.19, and the penalty they're paying to children is equal to now $8.76. Now, originally under the old system, the net revenue was $28.17 less $9.37, so they were taking home $18.80 per day. Now, new with the 10 videos, it's a difference of $31.19 versus a penalty of $8.76. So they're making net revenue of $22.43 a day. The difference between these is equal to $3.63. And since we know the movie cost $50, we can divide that by $3.63, and we get 13.77, which implies that in just under 14 days, they should be able to recoup the cost of that 10th copy.